Okay, so we're to start section 4.2. And if you notice, this is labeled 4.2a, hinting that there will be a 4.2b. Now, I'm not going to give you a video of 4.2b, but I am going to give you the worksheet to 4.2b. So if you were in class, 4.2b would just me reteaching 4.2a as a reminder very quickly, and then working on the worksheet for the rest of the class, helping kids as they needed help. So for you guys, we're just going to do 4.2a, the lesson. You're going to do the homework for 4.2a, the homework that's right here on this page. And then you're going to do 4.2b. If you want to replay this video again to give you a reminder of it, that's fine. If you just want to jump right back in to or jump right into the worksheet 4.2b, that's fine as well too. And the reason why we need to do this twice is because this is ultimately the key lesson of the chapter, which is 4.2. Okay, so literally what we're doing for the rest of the year typically is proving that triangles are congruent, and you'll see why we're doing this as the chapter progresses. All right, so last class we talked about if you were the same shape and the same, oops, that's not the same shape and the same size, but this is the same shape and the same size. If you were the same shape and the same size, then you are called a congruent figure. And the consequence of being a congruent figure is that the corresponding parts are congruent. The matching parts have the same values. And since we typically deal with triangles, we take that whole big statement, the corresponding part of congruent figures are congruent, and change that to CPCTC. The corresponding parts of congruent triangles are congruent. And as we start doing proofs, you'll see why this is helpful because you don't have to write the corresponding parts of congruent triangles are congruent. You can just write CPCTC. All right, so that means that the parts that go together have the same values. Remember, we can get this one of two ways. Way number one would be to look at the shape itself, but way number two, the more preferred way, is to look at the congruency statement to find the corresponding parts. So let's see, the corresponding parts, first letter with first letter, so A goes with D, B goes with E, C goes with F. And then for the sides, first letter, second letter, A, B goes with DE, so forth and so on. That was from last class. All right, so today what we're going to do, in fact, for the rest of the chapter and heck, for the rest of the book, we're going to be proving that this triangle on the left is the same as this triangle on the right. Okay, showing that two triangles are congruent. All right, many methods to do this. We'll start with the most obvious method. And the most obvious method to show that these two triangles are exactly the same is to show that all the parts are the same. So method number one, to show that these two triangles are congruent, I'm going to show that all their corresponding parts are exactly the same. Well, how many parts are that? There's 12 parts. There's six angles and there's six sides. So there's 12 things that I need to show. I need to show that the three angles of the left triangle are equal to the three angles of the right triangle. That's six. And then I need to show that the three sides of the left are equal to the three sides of the right. That's another six. So that's 12 things I need to show that the blue triangle is congruent to the green triangle. That's 12 things I need to show, right? If I can do that, then my conclusion is that the two triangles are congruent. And that's what you will be doing today, showing that the two triangles are congruent. And boy, is that a lot of work, right? That's 12 things. Six things of one triangle plus six things of another one equals 12 things. Is there an easier way? Clearly, there is, right? So let's talk about werewolves. Well, in mythology, werewolves are killed with silver bullets, and nobody likes werewolves. So the saying, "What's the silver bullet?" The saying, this, the metaphor of a silver bullet is a quick and easy way to accomplish something or to fix a problem. It's with a silver bullet. And so I refer to the ways to show that triangles are congruent as silver bullets, and there's five of them. And you're going to learn three of them today. So instead of proving that 12 things are congruent, we're only going to prove that three things are congruent. So think about this. All right. If I had three segments, right? I have segment one, the one in the middle, and then the one on the right. I have three segments, and I make a triangle out of these, right? So I have a left one, I have a right one, and I have a bottom one. That's how I'm going to force you to make the triangle this way. I got left side of the triangle, right side of the triangle, and the bottom of the triangle. See what I did? All right. Now what I'm going to do is I'm going to copy those segments. I'm going to copy segment AB. I'm going to copy segment BC. I'm going to copy segment AC. I gave them new names, but I literally made them the same distances. And now I'm going to force you to make a triangle again. And I'm going to force you to make that the left, that the right, and that the bottom. So the question to you is, if that's what you were required to do, would you make a different triangle? And the answer is, well, no, it would be exactly the same triangle. All the parts would be exactly the same. Okay. And if you can't figure out where this is going, we didn't prove that 12 things are congruent here. We only proved that three things are congruent, the three sides. So we need a name for this. We just showed that these two triangles are exactly the same, right? And we did it by showing that one side was the same as the second side, a second side was the same as that side, and a third side was congruent to the third side. So, we need a name for this, and we aren't too inventive. We are going to call this, if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. We're going to call this, can you guess? We're going to call it SSS, right? So this is a postulate, and this can be done either with tick marks. You see those two triangles on the left? Those are tick marks there, or it can be done with numbers. You see the two triangles on the right? Either way, I'm showing that three sides of one triangle are congruent to three sides of the other one, right? So the ones with the numbers, the same thing. And lastly, you can do it with a combination of tick marks and numbers. As long as you show that three sides of one triangle are congruent to three sides of another triangle, then by SSS, the two triangles are congruent, right? So instead of showing six things of one and six things of another, 12 total things, I simply need to show that three things. So this is postulate 12. Technically, I guess we just did prove it. You don't prove postulates, but I kind of walked you through the logic of it. So make sure this is our first silver bullet. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So we're going to call this the SSS. Now you would think if there's an SSS, there would be an AAA, right? Well, let's see if that's true. Well, this says we don't have one, and this is the reason why. Do you see these two triangles? Clearly, they are not congruent, right? They're similar, but they're not congruent. But if you were to measure the three angles of the one triangle, you would see it would 60, 60, 60, and that would equal the angles of the other one. So clearly, just because you have an AAA, three angles of one triangle congruent to three angles of another one, does not mean you can conclude that the two triangles are congruent. So yes, we have an SSS, but no, we don't have an AAA. All right. Remember our goal, show that the left triangle is congruent to the right triangle. We can do it the hard way, right? Show 12 parts, or we can show SSS. That's our first silver bullet, SSS. There are four more. We're going to get two more today, and then in about three lessons, we'll get the last two. All right, so SSS postulate. All right, there are some other shortcuts. All right, we'll work on our second silver bullet here. We need some definitions first. So this is where the lesson kind of drags a little bit. You'll forget what we're doing because we're just writing down some definitions. But I will use these definitions in the last two silver bullets. All right, first definition. Let's say I have a triangle and I pick one side. I'm going to pick AB. Notice that AB is opposite angle 1, right? So if I say angle 1, I look at the side opposite. That would be side AB. We're literally going to call that the opposite side. That's the definition. So it's the side of the triangle that is opposite a given angle. So I hand you the angle, you look at the opposite side. Now I'm going to do these quickly. Remember, you can always pause and write things down. All right. Well, if that's true, then we could do it in the reverse way. If I give you the side, then there must be an angle that's opposite it. So that's the definition of an opposite angle. So the angle of a triangle opposite a given side. So the only difference between an opposite angle and opposite side is what do you start with? To be an opposite angle, you start with the side. To be an opposite side, you start with we start with an angle. Hopefully that made sense. If not, rewind the video, play it again. Okay. Moving on, more definitions. Let's see. I got a triangle. I have all three vertices named here, and I have angle 1. Let's say I pick two sides, and I pick the two sides. You see how I pick those? I pick the two sides that kind of squeeze angle one. In other words, angle one is between those two sides, or you could say angle one is formed by those two sides. That's going to get a definition. So that's going to be called the included angle. And that is the angle that sits between two sides of a triangle. So the angle that sits between two sides of a triangle is called the included angle. Once again, these are going to come quick, so pause if you need to. Well, if that's true, right, then there must be an included side. And what would include side? Included side would be if you start with two angles and you look at the side that's between those two angles. That's what an included side would be. The side between two angles. So I start with angle one and angle two. The side that's between angle one and two is CB, right? I'm going to go back real quick, right? So we have included angle, right? The angle that's between two sides. And I have an included side. That's the side between two angles. Got it? Okay. So recap, let's see. If I start with angle one, the side opposite is called the opposite side. If I start with a side, then angle one is the opposite angle. Angle one is the angle that's between the two sides, so it's called the included angle. And that side there, CB, is between the two angles, so it's called the included side. So those are our definitions. I'm going to use these words in the last two silver bullets. All right. So where were we? We were talking about today, this lesson, this chapter, the rest of the book show that two triangles are congruent. Method number one, which we will never use, right, is to show that six parts of one triangle are congruent to six parts of the other one. That's 12 total parts. No, thank you, right? Or method number two are silver bullets, right? And the first one we said was SSS, and now we're ready to learn the another two of them. All right. So SSS was our first one. All right. There are other shortcuts, so think about this. Let's say that I start with this shape right here. Well, it's a triangle. And if you notice, I have an included angle. That's an angle between two sides. A is between side AB and side AC. And notice that's where the red tick marks are written. All right, so let's see if we can make a different triangle. So I'm going to take that triangle right there, and with the exception of the only part that doesn't have red tick marks, that would be side BC, I'm going to recreate a new triangle. So in other words, I'm keeping the red tick marks, but I'm allowing myself to try to make a different triangle. And the question is, could you make a different triangle? Or is there a way to connect G to H and make a different triangle? And the answer is no. It would be impossible. That angle F is fixed. It matches angle A. I can't change the length of side FG because it has to be the length of AB, and I can't change the length of FH. That's got to be the length of AC. And if that's the start or that's the requirement to make a different triangle, then the only triangle I can make is that one right there, which is a duplicate of the first one, right? So I talked you through the logic behind it. That's not necessarily a proof, and this is a postulate, right? So we need a name for this. So if we had two sides in the included angle, it would literally spell out, do you see it? SAS. So if two sides in the included angle of one triangle are congruent to two sides in the included angle of a second triangle, SAS, then the two triangles are congruent. And we call this the SAS postulate. Just remember, it must be two sides in the included angle. Just because you have two S's and an A doesn't make it SAS. It's got to be two sides and the angle between the two sides. And it's got to be for both triangles. If one triangle says SAS and the other one says, I don't know, A or SSA, then it's not true. They both have to say SAS. All right. Be super careful with this, right? Be super careful. These are SAS right here, right? There's other words you can spell with two S's and an A. You can use your imagination. Just be careful, right? It has to be SAS for both triangles. So here's an example of what it'll look like for homework. They'll say, are these two triangles congruent? So let's see. We look at the first triangle, and the first triangle has a side, has another side, and it has the included angle. So the top triangle is clearly SAS. The bottom one has two sides and the included angle, so it is also SAS. If both triangles are SAS, then yes, you can conclude that the two triangles are congruent because of SAS. I literally just wrote in blue what I already had in the slide. Okay, cool. So yes, these two triangles are congruent by SAS. All right. Let's look at the triangle on the right. If we look at the triangle on the right, I have two sides and I have the included angle. So that one is SAS. And it sure looks like I have an SAS on the second one, but be careful. Yes, you have an S and you have another S and you have an A, but it must be two sides in the included angle. If it's two sides in the included angle, it should have been this side that had the S, and that side doesn't have the S. The angle that has the S is this side. So if I read this rut-row, if I read this, it spells a bad word, right? And therefore, that ain't SAS, right? That one is SAS, right? Because it's two sides of the included angle. But this one is not SAS. In fact, it spells that word right there. Okay. All right, so that is literally the only joke that you can make in geometry class. All right, to show the two angles are congruent, now we have a second silver bullet, and that's called SAS. Just make sure it spells SAS. It's got to be two sides in the included angle. There's more silver bullets, just three more. We'll get one more today. So here's the last one. Think about this. If I had this triangle right here, and I wanted to recreate a new triangle with the same tick marks and arcs, so let's see, I have to make a side length AC equal the same length, and I have to make this angle A and angle C the same length. So if I did that, that's allowing me to make AB longer or CB longer because there's no tick marks there. So let's see if I can do this. If I extend this a long way up here, I'm changing the distance. Well, then I would have to connect it like this, and well, that's not a triangle. All right, well, what if I made it shorter? What if I made it like this long, right? That's shorter than AB. And if I connected this once again, that's not a triangle. So it turns out that if that's the restriction, I got to keep F the same as A. I got to keep H the same as C. I got to keep FH the length of AC. Then the only way to make a triangle out of that is just to extend the sides until they intersect. And if you see that, it literally makes the same angle. So this is needs a name. So if I have two angles and the included side, then the two triangles are congruent. If two angles and the included side are congruent to each other, then the two triangles are congruent. And that's our last postulate of the day. That's ASA. Once again, it has to be the two angles in the included side. It can't just be two A's and an S. And both triangles have to say ASA. If one says ASA and the other one says SAS, then the two triangles you cannot conclude are congruent. All right, here's your ASA example. I look at the left triangle. I have two angles in the included side, right? So that one, the left one is ASA. And if I look at the right one, that's two angles in the included side. So therefore, by ASA, the two triangles are congruent. How about this one? Let's see. Look at the one on the right. The one on the right, I have two angles, A, and I have the side in between them, right? ASA, that one's an ASA. On this one right here, I have two angles, angle, and that's the worst angle ever. Two angles, and I'm looking for the included side. The included side would be the side between the two A's. And notice that's not the side that they show that's congruent. They show that this is the side that's congruent. And if we spell that one out, go around in this direction, that's either AAS or SAA. In other words, it's not ASA. Therefore, these two triangles are not congruent. Or I should say, we can't conclude that the two angles. It's got to be, if it's ASA, it's got to be the two angles and the side between them, the included side. The one on the left there is not ASA, it's AAS or SAA. Three silver bullets, SSS, SAS, ASA. We will get the last two in about 2 lessons, 2 or 3 lessons from now. All right. So where are we to prove two triangles congruent? To show that blue triangle is congruent to green triangle, then we have three ways right now to do it. Eventually we'll have five, but for right now we have three ways to do it. And the bigger picture here as well is it has to be whichever one of those it has to be the same for both triangles. If the left one is SSS, in order to conclude that the two triangles are congruent, then the right one must be SSS. If the left one is SAS, then the right one has to be SAS. If the left one is ASA, then the right one has to be ASA. All right. And then lastly, there's a few combinations of A's and S's that we don't have. Remember, we do not have ASS, and let me show you why. So here's a triangle that literally does say A, S, S, right? So why does not this produce a congruent triangle? If you think about it, this gives me the freedom, just the things that are marked, this would give me the freedom to change this angle right here. So this angle right here doesn't have any arcs, so therefore I can change its length. I can also change the length of this side right here, right? So if I were to do that, right, then that means that I can change this angle, sorry, I can change this angle right here. So I'm going to change this angle right here. I'm going to move it around. If I moved it around, it would form this green arc right here. And since I'm also allowed to change the length of this side, notice we get not one, but we get two intersection points. It would intersect, that red line would intersect this dotted line at two spots. Well, that would mean I would have two triangles, this small one or this big one. And well, that's two completely different triangles. And that is why we don't have ASS. All right. So no book, no math book's going to say ASS. They're always going to say SSA. So there is no SSA, right? That's the donkey one. And then we also don't have AAA. So those two do not exist. All right. So lastly, remember both triangles have to spell the same things. The one on the left spells SAS, which we've got. It's one of our silver bullets. The right one says ASA. We've got that. That's one of our silver bullets. But both triangles have to say exactly the same thing. Typically, the first time you get this, the hardest thing to do is to read the triangles. Kids, I'll say, read the triangle. What does it say? And they're like, I'm not sure what I want you to do. I just want you to see if you have one of the three silver bullets, SSS, SAS, or ASA. SSS is easy. Nobody makes a mistake on that. But people will make a mistake on SAS and ASA. If it's SAS, it's got to be two sides and the angle between them. And if it's ASA, it's two angles and the side between them. So pay careful attention to that. All right. Let's do one proof. All right, so let's see. I've got a triangle. It says E is the midpoint of MJ, and it says that TE is perpendicular to MJ. So that is my given. And what am I trying to prove? I'm trying to prove the two triangles congruent. I now have three ways of doing it. Well, technically four if we consider that ugly way. I need to show that the left triangle is SSS, SAS, or ASA, and the same thing on the right triangle. If I can show either one of those three things, then the two triangles are congruent. So let's get to it. There's many things I could say here. It doesn't matter from the given. I have two statements I can make, and it doesn't matter which one. I'll just do one at a time. If E is the midpoint, right? Remember, we're going to try to go to either SSS, SAS, or ASA. If I go to the first statement of the given, it says E is the midpoint. Well, what's the consequence of being a midpoint? The consequence of being a midpoint is that you make two congruent parts. If you're in the middle of a segment, you've cut the segment in half. You made two congruent parts. Well, what two congruent parts? It says E is the midpoint of MJ. Well, that means that ME is the same as JE. That's just the definition of a midpoint or the consequence of being a midpoint. So that's statement one of the given. How about statement number two? Statement number two says things are perpendicular. Well, the consequence of being perpendicular is that they form a 90-degree angle, right? So that means I have two 90-degree angles. Which two angles? Well, MET and JET, right? Those are both 90-degree angles, right? So those two angles are congruent to each other, right? That's the definition of congruent. If the measurements are equal, right, then they are congruent. Okay. Now what? Well, here is the one trick that you will be using from now on. Take a look at the two triangles and really look at them, right? If I really look at them, I have a triangle on the left, I have a triangle on the right, but they're not drawn the way I just drew them. They're squeezed together. If you squeeze them together, that means they share a side. Well, if you share a side, that means you are congruent to yourself. That means that one side that's shared, TE, is on both triangles. Therefore, they must be congruent to itself. Remember when we talked about reflexive property and I said that we would use this quite often? We will. It just seems kind of silly, but we end up using that a lot, especially in this chapter. So yes, TE is congruent to TE, so I put two tick marks there. Now read the left triangle. Left triangle, look, we have two sides and an included angle. That's SAS. Look at the right triangle. We have two sides and the angle between them, right? So therefore, the two triangles are congruent because of SAS. And that's how the proof ends. All right. Homework will give you shapes like this and just ask you to state why are the two triangles congruent if you can prove that. The two tricks you need to pay attention to, I mean, you can kind of see that this one is SAS immediately. You can kind of see that this one is SAS immediately. But on this one, it's not readily apparent. Just like the proof we just did, look, they share a common side. So that we would have, oh, crud, we have ASS. So these two, you can't say that they're congruent. But this trick of reflexive property you might use frequently in the section in this chapter. All right. So this one right here is the donkey one, so not congruent. The other trick, there's a bunch of examples here. The other trick right here is right for this one right here. Notice, hopefully you see it immediately. Look, I got an X, so therefore I've got vertical angles and vertical angles congruent. All right, I'll just do these nine right here real quick. All right, number four here, it's pretty straightforward. Look, I got two angles in the included side. So ASA on the left one, ASA on the right one. On number five, look, reflexive property. That middle side right there, reflexive property. One, two, three. Therefore, that one's SSS. With the vertical angles on number six, that's an SAS. And now be careful, I am looking at both triangles. I'm not just looking at one of them. On number seven, oh crud, that's an ASS, right? So not congruent. Um, the one number eight is the one that typically gets people. If you look at the triangle on the left, that is clearly an SAS, and you will just want to write SAS immediately. But if you look at the one on the right, it spells ASS. So that one is also donkey. And then the last one, let's see. Yes, we do have reflexive property right here, but you can clearly see that the bottom triangle spells SAS, but the top one, once again, does not. So it is donkey as well, too. All right. I think that ends the lesson right there. Um, I'll just say typically students get a hold of this information. Some kids immediately are really good at this. Other students need about two lessons of this, hence the practice on 4.2b. So if it helps, take a day off, like between you doing don't do 4.2a and 4.2b just immediately 10 minutes after the other. Do 4.2a, take a day, then if you can do the worksheet 4.2b without watching 4.2 again, then great. If not, watch 4.2 again or 4.2a again before you try the worksheet. Hopefully all that made sense. If not, you can always ask me questions, and I will see you in the next class.